Alright, in this video we're going to talk about quantum numbers. Quantum numbers. So we got four quantum numbers, right? These are N, L, ML, and MS. So for these numbers are used to locate electrons. So we want to know the locations of electrons using these four quantum numbers. The very first one is called principal quantum number N. So here we have principal quantum number, which is N. So the principal quantum number is going to let us know what shell the electron is, right? So far you have seen a nucleus in your chemistry class if you took it in high school. So here you get the protons and you get neutrons in the nucleus, right? And then you have electrons on the shells. So this is the first shell, and you get the second shell, and so on. So here electrons can be in the first shell, like on this region here, and electrons can be on here, but not in between, right? That's something we know already. So electrons can be on the first shell, or can be on the second shell, or can be on the third shell, and so on. So this shell number is being described by using this principal quantum number N. Okay, so here the very first one is called N equals 1, the second one is called N equals 2, and it goes on like that. Okay, so the principal quantum number can be N, which is the first shell, the second shell, the third shell, the fourth shell, and fifth shell, and so on. Okay, so that's going to let us know where the electron is, or which shell the electrons is in. Okay, so that's the principal quantum number N. But also we got now quantum number L. So quantum number L is called angular momentum quantum number. Alright, so angular quantum number is called L. So what is this about? So now we know that electrons are buzzing around the nucleus, right? This is something we have learned in high school, but in reality that's not the only case we have here. For example, on the first shell electron, we are right. So electrons are just buzzing around the nucleus, right? They are doing this kind of shape all over the place. And it's not just doing 2 dimensions, also doing like 3 dimensions. So we see electron here as a sphere. So this electron is going to be moving around like this. So these are waves, right? These are not particles. So they are moving like this all the time. So here we have a sphere-shaped electron cloud. Okay, that is called angular quantum number L equals 0. Okay, so now there's a problem here. The problem is electrons are not just moving around as circles or sphere. So electrons are doing some other weird shapes as well, weird movements. For example, this electron on the second shell can do this behavior, like not only do sphere shape movement, also move like this. Since they are waves, so they can do that, right? So this is another wave, another kind of movement we can expect an electron on the second shell. So this is going to be a dumbbell shape. Also, we can have on the x-axis movement on this second shell electron, right? This is another possibility we can get. Also, we can have on the z-axis. So these are 2-dimensional objects, so they can have these kind of movements. So having different kinds of movements of electron or different shapes of clouds, we call them orbitals. Orbitals are clouds of electrons. So we got the sphere shape, we got the dumbbell shapes in here, but what kind of shapes we can expect an electron to have? Well, we got 4 kinds of shapes. The L equals 0, so we're going to call them S shape. We can call it a sphere shape, S orbitals. We can say the dumbbell shapes as P orbitals. And then we can say D orbital. And we can say F orbitals. So here we're going to talk about 4 different kinds of shapes. So far we know that the sphere ones is the S. So now the dumbbell type is called P. Okay? And we got D and F shapes. These are even weird shapes, so we are not interested here. Okay, so we got shapes, and then we have different kinds of shapes on every shell. So we need to number, because quantum numbers are going to be numbers. So we need to quantify with a number. So we're going to code this number using like this. So S will be L equals 0, P will be L equals 1, D will be L equals 2, and F will be L equals 3. Alright, so now we got different kinds of shapes of clouds on every shell, right? So again, principal quantum number tells us where the electrons are in the first shell, or on the second shell, or on the third shell. And here, angular momentum tells us the shape of the cloud, or the probability of electron in the area. So we just said that it can be a S shape, can be like a sphere, or can be a dumbbell shape, or can be D or F kinds of orbitals, which we are not interested to see them now. Alright, so we encoded these numbers as L equals 0, L equals 1, L equals 2, and L equals 3. Okay, I'm going to erase this one here. We don't need this. Okay, so now, so what? Alright, so these quantum numbers, the shapes, let's draw here another atom. The nucleus here, this is the first shell, right? And this is the second shell, and this is the third shell. So we can have a sphere on the first shell, right? This is the sphere one we can get. Also, we can have another sphere on the second shell, right? This is another sphere. This is just bigger, right? So we don't have only just one kind of S. We have like a bigger S sphere kinds of orbitals. So when we are writing down the orbitals here, we're gonna say this is gonna be 2s, and the black one here, the inside, is gonna be called 1s. So this number 1 and 2 are nothing, just the quantum number, right? So if you have the quantum number 1, we're gonna say this is the s orbital, the sphere shape of orbital on the first shell, and then here we have an s orbital on the second shell, right? Just bigger. They are the same kind, but the bigger. The same idea here for P, D, and F. So we can write down the principal quantum number as a coefficient for every angular momentum quantum number L. Okay. So what kind of orbitals or what kind of shapes we can expect in every shell? So the answer is here. Principal quantum number L can be 0, 1, 2, up to n minus 1. So what does that mean is that if you have I'm going to work over here. If you have n equals 1, you can have up to n minus 1, so it's going to be L equals 0. So we have only s orbital on the first shell, right? If you have n equals 2, so L number can be 0, 1, up to n minus 1. So n is 2, is going to be 1. So it's going to be L equals going to be 0 and 1. So for n equals 3, it's going to be L equals to 0, 1, and 2. For n equals 4, it's going to be L 0, 1, 2, and 3. So here, on the first shell, we can expect just the sphere, right? On the second shell, we expect to get s orbital as well as p orbitals. On the third shell, we are expecting to get s orbitals, p orbitals, and d orbitals, right? And then here on the fourth shell, we are expecting to get s-type, p-type, d-type, and f-type of orbitals. Okay, so now we know that the principal quantum number tells us how far from the nucleus. Angular momentum tells us the shape of the electron. And now we're going to talk about magnetic quantum number. Magnetic quantum number, which is ML. So this ML is about the shape. Okay, we got the shape, right? So we know the shapes in here, s orbitals, p orbitals, and d orbitals. So if you have L equals 0, which is s orbital, how different spheres you can get? Well, sphere is sphere, right? Whatever the direction is doesn't matter. It's just the same. So for L equals 0, for s orbital, we can have ML only one kind, that's 0. Okay? So what do we have for L equals 1? So the L equals 1 is the p orbital, right? The dumbbell shapes. Okay, so d orbital, the dumbbell shape, can have on the x-axis, can be on the y-axis, can be on the z-axis, right? So we got ML 3 cons. So we're gonna number them as -1, 0, and +1. So for p orbitals, dumbbell can have 3 orientations, right? Okay. And what about L equals 2? We're gonna have ML, we're gonna call them -2, -1, 0, +1, and +2. So we can get 5 kinds. Since we haven't seen the shapes, that's okay, but there are 5 kinds of orientations we can expect. They do not look alike, but they have these similar energies. All right, and then L equals 3, we're going to have ML value -3, -2, -1, 0, +1, and +2. Basically, ML number can be any number between -L to 0 to +L. For example, if you have L equals 3, ML will be -3, -2, -1, 0, +1, +2, and +3. If you have L equals 2, you're going to have -2, -1, 0, 1, and 2. So this is going to let us know the ML numbers. Again, let's go over what is quantum number N. It's going to let us know how far from the nucleus. L is going to let us know how the shape looks like. And ML is going to let us know how they are oriented in X, Y, Z dimensions, right? Okay. So now I'm going to talk about the spin quantum number, which is very easy. Spin quantum number MS. All right. So the principal spin quantum number is very easy to understand. So we get the principal quantum number. N is letting us know how far. L is letting us know the shape of the cloud, the movement of electron, and ML is telling us that shape, but what directions is going to be. And MS is going to let us know how this electron is going to move. It's going to move clockwise or it's going to move anti-clockwise. All right. So the principal quantum number can be +half and can be -half. So these are the only options we can get. All right. So now we got to do some practice questions. So you can see the practice questions on the next video. All right. Okay. I'll see you on the next video.